Hello everyone, welcome back to GitOps tutorial. In this previous episode, we learned what GitOps is, why it is important, and how Git becomes a single source of truth for Kubernetes deployment. Now that we understand the basic, the next question is, how should we organize our Git repository? A Git repository structure makes it much easier to manage application as your environments grow. It also helps teams work together and keep everything organized. In this episode, we will look at different repository strategy, learn some best practice and build a clean GitOps repository from scratch. By the end of this video, you will know how to create repository structure that is easy to understand, easy to maintain and ready for real-world Kubernetes deployment. Let's get started. In the previous episode, we learned that Git is the single source of truth in GitOps. Now the next step is organizing the Git repository properly. A Git repository is more than just a place to store Kubernetes manifest. The way you organize it has a big impact on how easy it is to manage your application. As the number of applications, environments and team members grow, a poorly organized repository becomes difficult to work with. Finding files takes more time, update become harder to manage and configuration mistake becomes more common. A clean repository structure makes everything easier to understand and maintain. The team members can quickly find the files they need, review the changes with confidence and manage application more efficiently. That's why designing a good repository structure is an important part of every GitOps implementation. Before designing a good Git repository, it's important to understand some common mistakes. The first mistake is placing everything in the repository root. When all Kubernetes manifests are stored in one location, the repository quickly becomes difficult to navigate as more applications are added. Another common mistake is mixing multiple environments such as development, staging, and production in the same location. This makes changes harder to manage and increases the chance of updating the wrong environments. Copying the same Kubernetes manifest into multiple locations is another problem. Over a time, keeping all those copies updated becomes difficult, and different environments may end up using different configuration. Finally, avoid random or inconsistent folder names. A clear and consistent naming convention makes the repository much easier to understand and maintain. These mistakes may not seem like a problem in a small project, but they become much more noticeable as your application and team grows. There is not a single repository structure that works for every organization. The right choice depends on the size of your team, the number of your application you manage, and how your teams works together. The first approach is mono repository. In this model, all Kubernetes manifests are stored in one Git repository. This is simple to manage and works well for small and medium-sized environments. The second approach is multi-repository. Here, Kubernetes manifests are separated into multiple repositories. For example, one repository may contain platform resource while other contains application-specific resource. This approach is common as environments grow. The third approach is repository-per-application. In this model, each application has its own Git repository. Every application is managed independently, making it easier for different teams to work without affecting each other. You don't need to decide which approach is best right now. We will compare them first, and by the end of this episode, you will have a better idea of which one fits your environments. In the next few slides, we will look at each strategy in more detail and understand where each one fits best. Now let's understand the first repository strategy, which is the mono repository. In this approach, all application, infrastructure, Kubernetes manifests are stored in single Git repository. One of the biggest advantages of mono repository is that everything is managed from one place. This makes it easier to track changes, review updates, and understand how different components are related. However, as the number of application and team increases, the repository can become larger and more difficult to manage. You also need to be careful when assigning a repository permission because multiple teams are working in the same repository. A mono repository is commonly used by small to medium sized teams or organizations that prefer managing everything from a single location. The next approach is the multi-repository strategy. In this model, Kubernetes manifests are organized across multiple Git repositories instead of keeping everything in one place. For example, one repository can contain platform resource, while other repository contain manifest for individual application or environments. This approach gives different teams their own repository, making it easier to manage changes independently. It also provides better access control because each team can be given permission only for the repository they manage. Another advantage is that repositories stay smaller and easier to maintain as the number of applications grows. The downside is that the changes may sometimes involve multiple repositories. This means you need good automation and clear process to keep everything in sync. That's why this approach is commonly used by growing organizations and large enterprise managing many applications and teams. The third approach is repository-per-application strategy. In this model, each application has its own dedicated Git repository. Every repository contains the Kubernetes manifest for that application, and each application is managed independently. This approach gives application teams more ownership. They can manage their own changes without affecting other applications, and permission can be controlled for each repository separately. Another advantage is that the changes in one application repository don't directly affect the others. Each application follows its own deployment lifecycle. However, when you have a many application, you will also have many repositories to manage. It can become harder to get an overall view of your environments, and teams should follow the common standard to keep repository organized. This strategy is commonly used by organizations where different teams own a different application and work independently. We have now looked at all three repository strategies individually. Let's compare them side by side. A mono repository uses a single Git repository for everything. It's simple to manage and works well for small team or organization with fewer applications. A multi-repository separates application and platform resource into a different repository. This provides a better organization and is a common choice for growing teams and enterprise environments. In the repository per application approach, every application has its own Git repository. This gives each team full ownership of its application and works well when multiple teams manage different services independently. There is not a single strategy that's best for everyone. The right choice depends on your team structure, the number of applications you manage, and how you want to organize your GitOps repository. No matter which repository strategy you choose, following a consistent folder naming convention is very important. Folder names should be simple, meaningful, and consistent across the repository. This makes it easier for everyone on the team to find the files and understand the repository structure. On the left, you can see a few examples of what to avoid: temporary folder names, inconsistent naming style, and mixing application manifest with platform resource can make the repository difficult to manage over time. On the right are some recommended practice. Use lowercase letter with hyphen for folder names. Keep application and platform resource in separate directories, and choose folder names that clearly describe their purpose. Following this simple practice keep your repository organized and make it much easier to maintain as it grows. Once you have chosen a repository strategy, the next step is organizing your Kubernetes manifest. A good practice is to group a resource by application. For example, keep the deployment, service, config map, and other resources for the same application in one directory. This makes them easier to find and manage. Next, keep the shared platform component separate from your application. Resources like ingress controller, cert manager, or monitoring components should have their own dedicated folders. It's also important to separate your environments. Deployment, staging, and production should each have their own directories, so changes are easier to manage and the correct configuration is applied to each environment. Following this structure makes your repository easier to understand and maintain as more application and environments are added. Regardless of which repository strategy you choose, there are few best practices that every GitOps repository should follow. First, avoid keeping duplicates Kubernetes manifest. Having multiple copies of same configuration makes updates harder and increase the chance of inconsistency. Keep your Git history clean by writing meaningful commit message. This makes it much easier to understand what changed and why. It's also a good idea to include README file. A simple README helps team member to understand the repository structure and its purpose. Another important practice is to store only the source manifest in Git. Avoid committing temporary or generated files that are created during deployments. Organize your directory based on their purpose. Keep application manifest, platform resource, and environment specific configuration in separate location so the repository remains easy to navigate. Finally, keep your manifest readable. Use consistent formatting and clear names so anyone on the teams can quickly understand the configurations. We have covered the different repository strategy, naming conventions, and best practices. Now let's put everything together and look at an example of a clean GitOps repository structure. At the top level, the repository contains a README file that explains the repository and its purpose. The app directory contains the Kubernetes manifest for individual application. Each application has its own folder, making it easy to find and manage its resource. The platform directory contains shared platform components such as ingress controller and monitoring tools. Since these resources are shared across applications, it's a good idea to keep them in a separate location. The environments directory contains environment specific configuration such as development, staging, and production. This keeps each environment organized and easier to manage. This is one example of a repository structure. You can adjust it based on your organization requirement, but the main goal is to keep the repository organized, consistent, and easy to maintain. Now it's time to put everything we learned into practice. In this demo, we will start by creating a Git repository and cloning it to our local machine. Next, we will create a clean folder structure for application. After that, we will add a few sample Kubernetes manifest and organize them into an appropriate directory. Once everything is in place, we will review the final repository structure to make sure it is organized properly. Finally, we will commit the changes and push them to GitHub. By the end of this video, you will have a clean GitOps repository that is organized, easy to maintain, and ready for GitOps deployment. In the next episode, we will use this repository while installing and exploring Argo CD. Now let's switch to the terminal and start the practical demonstration. Let's begin by verifying the Git is installed on this machine. If Git is installed, you will see installed version. If you are using Git for the first time on this system, configure your Git username and email. This is one-time setup and is required when creating commits. Enter your username, GitOps, global user.email, and you can mention your email ID. For now, I will mention like GitOps-email example.com. You can verify config global user.name, and similarly you can check email. Here you can verify that your username and email ID have been configured successfully. Now let's clone the existing repository. I have already created a GitHub repository for this GitOps and Argo CD tutorial series. Instead of creating a new repository, we will continue using the same one and add a separate folder for episode 2. GitHub, GitOps. So now we will clone it. This is the repository. Just you can copy it from here. Minimize. Git clone followed by the URL which you have been copied. Press enter. There is some network issue. Let me try once again. Now it works. Currently, this repository contains the content from episode 1. Now let's create a dedicated folder for episode 2. To keep the repository organized, I will create a separate folder for this episode. mkdir episode 2. This is the path. All the files and folders that we create in this demo will be stored inside this episode 2 directory. Now let's create a directory structure that we discussed in the theory session. I will create mkdir apps. Another folder will be platform, and the third folder will be environment. 3 folder is created. mkdir, I will create folder, subfolder in apps named as Nginx. Apps followed by MySQL, and also we will create a subfolders in platform as well as in environment folder. First create a subfolder in platform, mkdir platform ingress -nginx, platform, another folder monitoring, and we'll create a subfolder in environments named as dev, again environments, staging, environments, prod. The app directory will contain application manifest, platform will contain shared platform resources, and environments will contain environment specific configuration. A simple way to view the directory structure is by using the tree command. Let's see if the tree utility is already available on this machine. Yes, tree is already installed. If you don't have the tree utility installed, you can install it using your Linux distribution package manager. Assume you are using RHEL or a Rocky Linux. You can run command sudo dnf install tree-y. This will be the command, and if you are using Ubuntu or Debian, you can run sudo apt install tree. And once you are installed, you can run tree command. The tree command gives us a clear view of our repository structure, which is very useful when working with GitOps repository. It's a good practice to include README file that explains the purpose of this repository. I will create a README file, readme.md. We'll add a simple text, save the file. Another good practice is to create a .gitignore file. It prevents the temporary or unnecessary files from being committed to Git. So I will create vim.gitignore. Here you can do star.swap tmp .ds underscore store, save the file, .gitignore. This is just a simple example. In real project, the contents of .ignore file depends on the tools and the files used in your environments. Now let's add a few sample Kubernetes manifests to demonstrate how application resources are organized inside the repository. In apps nginx, here I will do deployment.yaml. Let's do cat. This deployment defines two nginx pod. For this demo, the focus is on how the manifest is organized inside the repository, not on deploying the application. Next, another file vim app nginx. I will create service.yaml, adding the YAML files, save the file. This is the file. This service exposes the nginx application inside the Kubernetes cluster. These sample manifests are included only to demonstrate how Kubernetes resources are organized in a GitOps repository. We will deploy them to our Kubernetes cluster in the next episode using Argo CD. Let's review the directory structure we have created for this episode 2. This is the directory structure. This structure follows the GitHub repository organization we discussed earlier. Application, platform resource and environments are organized into a separate directory, making the repository easier to understand and maintain. Before committing the changes, let's check the current Git status. Git status. Git shows all the new files that have been created but are not yet being tracked. We will run git add git status. All files are now ready to commit. Let's commit it. Commit -m. In double quote, you can add like add episode to GitOps repository structure, git log, the repository now contains its first commit, git push origin mean. It looks like authentication failed because GitHub no longer accepts the account password for the Git operations over HTTPS. We need to use personal access token instead. Cloud native. Let me access the GitHub repository. Let's refresh here. Here you can see episode 02 repository structure. This repository we have created. After refreshing the GitHub repository, you can see the episode 2 folder now contains the complete GitOps repository structure we created in this demo. Let's minimize it. In this demo, we create a GitHub repository, organize a clean directory structure, added a sample Kubernetes manifest, and pushes everything to GitHub. Our GitHub repository is now organized and ready for the GitHub deployments. In the next episode, we will install Argo CD, connect it to a Git repository, and begin our GitOps workflow. Now that we have completed the practical demonstration, let's switch back to the slides and quickly recap what we have learned. We learned why a good repository structure is important and looked at some common mistakes to avoid. We compared the three main Git repository strategy: mono repository, multi-repository, and repository per application, and discussed when each one is a good choice. We also covered folder naming best practices, learned how to organize Kubernetes manifest, and build a clean GitOps repository structure that is easy to manage and maintain. In this demo, we created the repository, organized the folder, added a Kubernetes manifest, and pushed everything to a GitHub. In the next episode, we will install Argo CD, explore its architecture and components, access the web interface, and connect it to a GitOps repository we created in this episode. If you found this video helpful, please like the video, share your preferred repository strategy in the comments, and subscribe to TechOps tutorial for the upcoming episode in this GitOps series. Thanks for watching, and I will see you in the next video.